Alrighty, I'm back. So that was finished up 1.5, the last question, because the mic had cut out last time. So that doesn't happen on this stream. Well, I said yesterday, basically, when the mic cut out. I want to make sure that everything works. So, and that was just, I don't know why that happened. Okay. All right. Well, looks like we are in business. And yeah, let me just, let me pause this. Okay, that's good. Perfect. Well, let's get into it, shall we? I'm gonna start the usual thing, and then I'm gonna start a new page. All right. The book is Book of Proof. If you go in the video description, just click on that, and you'll be able to download it right here. Book of Proof by Richard Hammock, and just go in the video description. Go to the back of the book. You'll know if I get it right before I even do. We are 1.6. I'm doing this primarily to improve my own math skills because that's my major. Okay. Okay. Well, let's start answering this. Get a drink real quick. Pretty straightforward. Okay. Um, so, take this off. Make sure I'm still going here. All right. So, just gonna add something. U minus A is equal to A hat. All right. If we take the universe and we subtract A, what remains is called A hat, or A top, the complement of A. We're going to call it the complement of A. Because something you'll notice, this is the kind of thing that worries me a little bit. Because I'm just a student, I'm not a teacher. I tend to use math lexicon in an idiosyncratic way. So what happens is I say something and, just don't go quoting me to your teachers. It's going to raise some eyebrows. All right, let's do this. Anything that's not in A but is in U. All right. Wait a minute. You know what? This is gonna irritate me. We're gonna rewrite this. Easier to work with numbers when they're in order. And that's something that's called well-orderedness. It's gonna be very important later. A lot of number sets do not have that feature, such as like the real numbers. It's hard to order them because you could subdivide them. You can't put them one for one because in any two real numbers, you can go between them and pull out another number that's the half of the two of them. Okay, so So it's pretty straightforward. Anything that's not in A is called the complement of A. So yeah, just that was the complement of B. And as for C, okay, obviously there's no intersection because by definition, anything that's not in A is in the complement of A. That's in U. So yeah, that D. Okay, that's obviously U. So since A and the complement of A have nothing in common, subtracting the complement of A does nothing to A. Okay, now in this case, what is the complement of B? Okay. Okay, A loses 1, and it loses 3. 4 remains, and 6. Yeah, looks like it's just 4 and 6. 4 and 6 are not in B, and that's it. Huh. F. Okay, we need the complement of A. We have it down here in A, that's fine. All right. Okay. A loses 0, A loses 2. 5 is okay. And 8, I think. 10 is gone. G. H. Okay, let me have the intersection of the complement of A and B. So where do they intersect? What is the complement of A and B? What do they have in common? 8. And 5. Yeah, and 5. Wait a minute, wait a minute. What am I talking about? Yeah, 8 and 5 are the only things that the component of A and B have in common. I'm going to say 5 and 8. Keep them in order. I. Okay. The complement of the complement of A which intersects with B. So again, we're going to solve for the complement of A and B, which we know. And then we're going to take the complement of that. So basically, we want the complement. Okay. Okay. Well, I just gave C an assignment. which is equal to C complement, which is equal to C is equal to 5 and 8. So the complement of C is 0, 1, 2, 3, 4, 6, 7, 9, 10. All right, I answered 9 questions in the first one. And okay, yeah, that's fine. Let's see here. We have to check the answer. I'm feeling pretty tired with work, sleepy too. But I gotta tell you something that even though I'm dragging my feet here, once you form a habit, it's much easier just to keep doing the habit, even if it's exhausting. You stream everyday math, you start to have the drive to do that every single day. It's great. It's good. Let's see here. 5, 8, 10. Yes. 1, 2, 3, 4. Yes. 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 And yes. The book agrees. They're all correct. All right. All right. I remember how much of a mess I did of the sketching last time. Yeah, let's see if I can do better than that. I'm just gonna. There we go. All right. And then we're gonna do 3. And then we have the set X, which is equal to closed braces, so 1 by 3 by 1 by 2, which is equal to, yeah, at this point, this should start to become second nature. Ordering pairs. Okay, we ordered that set. It didn't take long. Double check your work. 1, 1, 1, 2, 3, 1, 3, 2. So far, so good. Sketch on R2 on separate drawing, shade in. Okay. Okay, sure. Why not? Okay. Now, so notice how we're staying in the positives. We can just do this. We're gonna be rebels today. Just kidding. There's nothing rebellious about this. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 4 and 4. Okay, so we have 1, 1 closed. X equals 1, y equals 2. 1, 2. X equals 1, 2, 3. Y equals 1. There we go. And 3, 2. All right, check your work. I screwed this up last time. Made a lot of work. It was kind of moot, but okay. 1, 1. 1, 2. 3, 1. 3, 2. Okay. All right, so this is X. And sets, okay, so this is going to be X. This is just shading. Okay, and yeah. Okay, so if this is X, everything else that exists, all right, throw a new layer. Doesn't matter if it's positive or negative. It is going to be X, the component of X. And the whole thing, if you add the component of X and X together, you get the universe. Okay, so then let's see here, sketch this. And all right, so this is one answer. Let's just hang on. Well, I'll finish up the last one, and then the intersection of, okay. Okay, good, awesome. New layer. So the intersection of the component of X and 0, 2 and 0, 3. So let's just order the set. Okay. Let y equal actually they didn't use curly, so we're not going to do that either. So this is for my own convenience. I'm going to order the set. In other words, I assigned it to y so I can refer back to it as y. Okay. So we want to know the intersection. We have this. We're going to say okay. See how I did that? I just referred to it as y. So where do they intersect? Well, in other words, I have to mark this, but it cannot be inside the box, our X box. Yeah, okay. Yeah, we cannot be inside the X box. Okay, 0 and 3. And then X equals 2, Y equals 0. Okay, there we go. 2, X equals 2, Y equals 3. So we're going to go like this. Now, yeah. Now here's the thing. Where it borders the X box, we're going to put dashed lines like this. Because technically X occupies that area. So that area, we're going to say it's open. But everything else is going to be like this. Not bad. I'm getting better at this. Not bad at all. Okay, well, let's see what that looks like. Yeah. And yeah, going back to the previous thing that I said with the universe, let's go back here. I perhaps didn't make it clear enough. I will make it clear. So when you write dashes like this, that means that you get as close as you physically can without actually being there. It's like the limit approaching that area, but you cannot actually be on 2. You can get as close as you physically can to 2, but you cannot be on 2 because that's a closed area. And because of that, the component of X, since it and X have nothing in common except if you add them together, you create the universe. So they both can't be in the same spot. It's important. Okay, good. So far, so good. All right. All right, let's go here. Sketch the set X. We're gonna got. We're just flying right through this one. Now, this is the thing that tormented me and got me to do trigonometry, because that sure looks like that. So right away, you recognize the unit circle. That's important. So we have the set X, where the ordered pair X and Y are members that contains, just say members also, are members of R2 space, such that 1 is less than or equal to X squared plus Y squared. That means another way to read it would be X squared plus Y squared is greater than or equal to 1. That means it's like a unit circle, but it's inverted. So they do occupy the unit circle, but they are bounded outwards, but they are less than 4. So it's a donut, I'm guessing. This is what it looks like. Just by like, yeah, this is like a 4-unit donut circle. So unit circle is going to be 1, 1, 1, 1, 1 minus 1 minus 1. What? 1 minus 1. Okay, and then we have 2, 3, 4, 2, 2, 3, 4, 2, 3, 4, 2, 3, 4. Negative. Okay. So let's just start with the first part. So basically, we have this equation right here, which is a unit circle, and we can apply the first part of it. X is greater than or equal to 1. So we do occupy the unit circle. Why don't we switch colors? Here we go. So we do occupy that. Equal to, so we do that. I know it's a terrible looking circle, but take my word for it. It's a circle. It's a unit circle. Stick around for my trig streams. You'll know all about it. All right. All right. Something like that. I have like an airbrush tool. Oh, this is cool. It's an airbrush tool. Wow, I'm learning so much today. Okay, so that, and so this is the first part. And then we have less than or equal to 4. So we can go to 4. Look at that. I don't mean to brag, but I think we just invented the CD. Okay. All right. Hmm. I did it wrong. And I think I know why. I just need a minute to figure out. It's not a major mistake. I mean, it is a major mistake. We get partial credit for it, but I need to see. I did not solve. This is why I was doing trigonometry, by the way. This is the part that pissed me off so much that immediately after my previous stream, I went straight into trigonometry, which I'm going to continue doing, by the way, for obvious reasons. I keep making these silly mistakes. Okay, let's take this one. All right, so let's just write this way: x squared, and we're going to square root this, plus y squared. We're going to square root this is going to be greater than. I just flipped around the order. Root 1. So that means x plus y equal to 1. Okay. So if we did that, by the way, the square root of 1 is still 1. So if you look at that, yeah, that should more or less be right, I think. If I had a grid, it would probably be a little easier. Well, actually, I can make a grid. Try that in a minute here. There we go. I got a grid. I want to try something first real fast here. So let's just draw this for a minute. Okay, that's 10 unit. Okay, 10 unit. Okay, you'll see what I'm doing in a second. Okay, so where x is half, y is half. So that's slightly not right. passes through this one. And maybe kind of hard to tell, but yeah, let's say about here somewhere. It's roughly where it passes through. So that's 7, roughly. 8. 1, 2, 8. So that's about 8. Okay. So again, stick around for my trigonometry stream, and you'll see what I'm doing here in a minute. Man, those unit circles are driving me nuts. Well, here's the thing. The problem where I got this wrong isn't the first part. First part is correct, actually. It's the second part that threw me off. So x squared plus y squared is less than or equal to 4. And we have here, it's saying that it ranges from 2. So, right. Of course it would be 2. Oh my god. Yes, because x squared is equal to 4, and which would mean x equals to 2. So where x is 2 equals 2, y equals to 0, and where y equals to 2, x equals to 0. Okay. Right. That's the correct answer. All right. Right. I'm trying to establish this arc right here. Don't worry about that. Just know the formula for the unit circle and then just draw a circle. Okay. That's really the trick to it. And then let's fix my little mistake here. We're going to take this. So we said this was 4. We said the beginning here was 1. So we're going to, here's what I'm going to do. I'm just going to do this. I'm going to take out my intervening units. There we go. And then we're going to say the first unit is 1. Okay, so this is going to range from 1 to 2. And tighten it up a little bit. Doesn't look so big. It has to be, because it can't be more than double the length from 0 to 1. Right? Okay. I prefer creating an accurate picture, you know what I'm saying? Okay. Let's correct that. So then this is 1 and this is 2. This is 1, this is 2. Our notches. 1, 2, -1, -2, -1, -2. Okay. Now, it is contained within it. So we're just going to put a hard border on it. Again, it's not going to be a perfect drawing, but as long as it's accurate enough looking, it can be a little wonky in terms of my freehand abilities, but as long as the graph is represented accurately. That's correct. And fundamentally, what I should have done is just take x squared plus y squared is less than or equal to 4 and solve it in terms of 4. Now, when I'm solving in terms of 4, you just kind of go approximately this way. We're going to say x squared is equal to 4 minus y squared. So then, there's a couple ways you can do this. Just because it's an easy one, you can just throw the numbers in, or you can plop that in. Wait a minute here. And if we take that 2 minus, so yeah, basically, then we square root this, square root this, square root this. So it's going to be x is equal to 2 minus y, and probably. Oh, hold on. Okay, hang on a minute. Hang on. It doesn't. Okay. Just we'll worry about that in trigonometry more. But the idea essentially is, um, that's not exactly correct. What we want to do is we want to set up ordered pairs. So the approach simply is that here's what we do. Right. We know it's a circle because of the unit circle. What we want to know is where is x where y is 0. Even if you didn't know that it's a unit circle, here's what our equation is. X squared plus y squared is equal to 4. So less than or equal to 4, but we're just going to say equal to for now. So then we are going to say x, y. When y is 0, what is x? So x squared plus 0 is equal to 4. We're going to root. X is equal to minus 2. We're going to say plus minus 2. That's what x is. Negative 2 and 2. And the same thing applies for y. It's the same form of equation. If x is 0, y would be negative 2 and 2. So then that's how we know our polar coordinates. That's the way to solve it. Instead of this whole me going off on a trigonometric tangent, which is good, but what I should have just done is figure out where when x is 0, then when x is 0, figure out the y. When y is 0, then you'll know the x. Okay. That is okay. We did that on a separate drawing. Shade in the set of the component of x. Okay. Right. So we're going to say x. Let's not put it there. So the component, so basically it's like this. X, let's use black for a minute. U minus x is equal to the component of x. X and the component of x together create the universe. The universe means all there is, all in your R2 graph or whatever you want to limit to, or it could be a set of numbers as we were doing it. So earlier in the stream, but basically, yeah. Now in this case, I'm gonna have to show you what happens at the border. You put these dashed ones, not a solid one, but you put dashes. That means it's an open thing. That means you get as physically close to it as possible without actually touching it, because the x in this case, it's a closed brackets. So I'm representing this as you would with empty bracket or open brackets. You can get to as close to it as you physically can without actually being there. Because they will never touch. X and the component of x they together make up the universe, but neither shares anything with the other. They are direct, not opposites, but they complete each other to create the universe while sharing nothing together. Yeah, you put that in the manga somewhere. Actually, that reminds me of, there's a certain manga where it ended on a similar principle. The guy who did Chainsaw Man, he had another manga before that. What was it? Look this up here. Chainsaw Man was pretty good, by the way. It's written by Fujimoto. Um, Fire Punch. That's what it is. So yeah, without giving away the story, that whole thing, what I said about components and the universe, in a weird way, that's the very end of the manga. Kind of ends on that. So I'm not gonna give away exactly what happens, but yeah, Fire Punch is even better than Chainsaw Man, even though it's an earlier work. It is a wonderful, wonderful manga. I mean, it's pretty horrible in a sense because it talks about some really hard stuff. A guy who basically ends up being set on fire, and he is constantly regenerating, a la Wolverine. So he's constantly on fire and constantly regenerating, and that's how the story starts. And it goes in some very weird places. Um, yeah. So, all right, let's check the answer. Hmm. Yes. Yes. Good. Okay. So far, so good. Um, Venn diagram. Okay. So that's the next thing. Mm-hmm. That's another short one. Okay. Yeah. 8's gonna be perhaps a little 1.8. 1.7 is another short one. And then we go to logic. Start writing truth tables. Sections. I just want to look at this for a second here. Oh yeah, this is gonna be fun. Um. Okay. Cool. All right. Well, that's the end of this stream. We have covered 1.6, and now, because trigonometry keeps bothering me, I'm gonna start a new stream. This is continuing from yesterday's position there. So what I'm gonna keep doing is I'm eventually gonna add calculus. I have the OpenStax calculus books. And by the way, if you want this book, it's linked in the description. Just download it. It's free. It's part of the open source courseware. So yeah, it's a very fortunate thing that we have it, or buy it. It's a very nice book. But yeah, I found a nice open source book for linear algebra. Eventually, I'm gonna be doing all that stuff. Anyway, all right, that's it for the stream. Have a good night.